Hello, my name is Beh Jen Xiang. So today we have a short review on investigation and adaptation of kernel fiber in various types of reinforced polymer composite from a fundamental standpoint. So at first, we must know what is fiber. So fiber is a material that are constantly renewed by the environmental or humans. So natural fiber offer benefit over them such as the low density, larger modulus, uh, greater cost, and a wide variety of natural sources. So if we compare to synthetic fibers, natural fibers are derived from the plants or animals which are renewable and environmental friendly. So this is the classifications of the natural fibers. So we will talk about what is natural composite. So the composite material can be categorized into several classes based on the components that make them up, including fiber, composite, or synthetic composite, specialty composite, and laminate composite. So we will focus on fiber composite. The natural composite materials such as bamboo, wood, and human muscles and bone have a high potential for replacing metals and synthetic fibers. So in this context, a well-known natural fiber in Malaysia, kernel fiber, will be used in reinforced polymer as a biocomposite. So we will talk about how we produce the kernel fiber, which is from the kernel plant. So kernel plant is sturdy and hardy, requiring little pesticide and exhibiting great resilience to insect infestation. So Knaf also grows well in variety of soil type and need little in the way of chemical treatment to flourish. So usually just one application of herbicide and a little amount of fertilizer is needed for them to grow and live. So we will talk about the characteristic of the Knaf fiber. So first we will talk about the physical and the mechanical properties. So Knaf fiber is a those thick fibers, which with the excellent endurance and a high aspect ratio, making it perfect to reinforce polymer composite. So it is also soft and robust, making it an excellent choice for automotive components such as bumper and dashboard. So furthermore, the mechanical properties of kernel fiber are determined by the site where the fiber stock is harvested. So the fiber take from the stock core are often stronger, larger, and stiffer. So right now we will talk about the chemical properties. So kernel fiber are made out of water soluble components, which are cellulose, hemicellulose, lignin, and wax. So their cell wall is actually composed of hemicellulose uh, or hard crystalline cellulose. And the kernel fiber also have a very high cellulose content, which is from 44% to 64%. So, according to a finding, the large variability in chemical composition can be related to the variance in testing method. So, the testing method will be affect the chemical position um, after the testing. So right now we will talk about the preparations and applications of the selected natural fiber reinforced polymer composite. So first we'll talk about the kernel polypropylene fiber reinforced concrete. So we'll talk about the methodology. So how we produce it. So two type of fibers. which are the kernel fiber and the polypropylene PPF are prepared. So the kernel fiber underwent the numerous treatment before being cut to the necessary size. And each concrete mix used in the experiment consists of cement, water, fine and coarse aggregate, as well as the variable quantities of fiber. So the fiber were added to the mixture once it had attained a homogeneous consistency. So the application is the kernel polypropylene fiber reinforced concrete will be used as the construction materials, uh, which being ecologically friendly and sustainable. And also the adding of PBF will boost the strength and decrease the plastic shrinkage. And with the fiber content increase in in the concrete, it demonstrates a great water absorption as the kernel as a natural fiber absorb it. So this is an example or the picture of the kernel fiber and the polypropylene. And this is the picture of kernel polypropylene fiber in forced concrete. So second, we will talk about the kernel fiber reinforced epoxy composite. So we will talk about the methodology. So the epoxy composite will be made by the casting resin and the kernel fiber. So first, the resin casting procedure mixing of the epoxy and the hardener at the room temperature. So the resin and will be poured into the prospect mold sheets, and then the bottom of the mold will be clamped and left the top unclamped for the opening following the resin casting. The wax was also used as a mold release agent on the interior surface of the mold, and the treated and the untreated kernel fiber were generally dispersed before pouring the resin. And then after 2 days drying, the composite was taken. So as you can see for the picture at the left side, this is a method of the casting kernel fiber reinforced epoxy resin. So how can we use the kernel fiber reinforced epoxy composite? So actually there are some benefit for the kernel fiber reinforced epoxy, which is less expensive, heavier, and more visually attractive. And there are some improvement in tensile parameter such as tensile strength and modulus of elasticity. And with the higher fiber content, have faster disintegration rates, better load bearing capacity, which are the advantage um, after mixing the kernel fiber with the epoxy resin. So we will talk about the kernel fiber reinforced geopolymer concrete. So of course the kernel fiber reinforced geopolymer concrete mixes as fly ash and mix for 3 minutes. So actually is the first fine core aggregate will be mixed with the kernel fibers and then later will be mixed with the fly ash. So to produce a homogeneous mixture, the kernel fiber was added to a dry ingredient mixed for 3 minutes. And then the alkaline activator solution was added. So the first geopolymer mixes were then deposited in 3 layer in mold, which each layer crushed on vibration tables for 50 seconds and remove airspace. So then the KFRGC specimen are allowed to cure or at the room temperature for 1 day. So about the application, so the KRGC is an eco-friendly alternative to cement in building to reduce the world CO2 emission. It can also withstand high temperature and as well as increase its mechanical and impact strength. So it also improves the water absorption and effective porosity after adding the canal fiber into the geopolymer concrete. This is the visual explanation of geopolymer concrete. So this is the fourth one where we talk about the canal fiber reinforced polylactic acid biocomposite. So in this methodology, we will use the superheat steam oven (SHS). So first, the SS oven is switched on, and then the carbon fiber will be spread out on the tray coated with aluminum foil, and then placed in the SSH oven for heating. And then after the treatment is finished, the fibers are immediately taken from the heating chamber, allowed to cool in the desiccator, and sealed in the plastic bag. And then the fiber will be manually combined with the polylactic acid (PLA) to create a biocomposite combination. So what is the use of the PLA? Actually, is the PLA is a natural, environmentally friendly polymer which is ideal for the 3D printing application. So with the combination of canal fiber with the polylactic acid, it will minimize the waste from the toxic non-biodegradable petroleum-based polymers. And before the canal fiber reinforced polylactic acid biocomposite to be acceptable as a whole grain alternative for 3D printing, it must be evaluated if the biocomposite filaments meet the requirement. So this is the picture of the filament. So the A will be untreated for the untreated canal fiber. The B will be the treated canal fiber mixed with the polylactic acid. So this is a 3D printing sample. So next we will talk about the canal fiber reinforced unsaturated polyester composite. So first the canal fiber was inserted in the mold and then treated with the MEKP, which act as a catalyst. And then those standard steel sheet were put on top and the bottom of the mold to enclose the UPE impregnated canal fiber mat. So and then we will have a cold press using a Gotek testing machine and then let it cure for 1 day at room temperature. So the application of the canal fiber reinforced unsaturated polyester. So it is suitable for the automobile and outdoor applications. And the other advantage is it is inexpensive and absent of byproduct during the curing process and high mechanical and curing qualities. The hand layout methods can handle all sorts of canal fiber, including non-woven mats, long fiber, and short fibers, has grown popular. So this is a stacking sequence of the canal fiber and the polyester matrix. So this is the last one where we talk about the canal fiber reinforced polyethylene composite forms. So how do we produce it? So we first clean the fiber and then mix with the natural canal fiber reinforced hybrid polyurethane composite. using magnetic stirrer. So this combination was then immersed in ultrasonic bath and then subjected to ultrasonic wave for 10 minutes to distribute the fiber. So, and the isocyanate polyol system were then combined using a mechanical stirrer to make the needed sample. So finally, the natural canal fiber reinforced composite were then delivered. So how do we use the canal fiber reinforced polyurethane composite form? So it has excellent sound absorbing properties due to the cavities, channels, and gaps in its structure. So it is suitable for making as a sound absorber. So it also has the adaptability, numerous qualities, and ability to connect with a variety of materials. And PU is commonly employed in the development of multifunction hybrid composite. So the dilemma of the PU composite form reinforced with the fillers, such as natural fiber, gaining popularity since this natural fiber may improve the PU form in a number of applications, including industrial and solar setting, which also being cost effective and ecological being. So this is the kinetic of PU form composite enhanced with the kernel fiber. So in contrast to other fibers such as the carbon fiber, kernel fiber is a renewable resources that can be rapidly cultivated, making it supply virtually inaccessible with enhanced properties and eco-friendliness. So that's all from my presentation. Thank you.